Have you ever wondered why some winters are bone-chilling and snowy while others are surprisingly mild? Or why the weather can seem so unpredictable from one year to the next, leaving us guessing what's coming next? Why do some regions get drenched with relentless rain and floods while others are left parched and cracked by drought? The answer lies in a force of nature that shapes weather patterns across the globe. At the heart of this global weather puzzle is a powerful engine in the Pacific Ocean: El Niño, a phenomenon that can tip the balance of weather worldwide. El Niño is part of a larger natural cycle called the El Niño Southern Oscillation, or ENSO. This cycle is a complex dance between the ocean and the atmosphere, sending ripples through the climate system and affecting weather everywhere. El Niño doesn't show up every year, but when it does, its impact is felt far and wide. It can devastate crops in Peru, disrupt fishing industries, and bring heavy rains or severe droughts to distant lands. Even winters in North America can be transformed, with some areas buried in snow while others experience unusual warmth. That's why scientists around the world keep a close eye on El Niño. Its reach is truly global, reminding us that weather in one place can be connected to events half a world away. In this video, we'll explore what El Niño is, how it forms deep in the Pacific, and the science behind its dramatic effects. We'll see why understanding El Niño matters for everyone: farmers, city dwellers, and communities across the planet, because its influence touches us all. We'll also meet El Niño's cooler sibling La Niña, and discover how these two opposites can trigger wild swings in weather, sometimes back to back. This back and forth is known as climate whiplash, a roller coaster of extremes that can challenge communities and ecosystems. By the end, you'll understand why tracking El Niño is crucial for predicting the future, preparing for disasters, and adapting to a changing world. So, let's unravel the story of warm water, shifting winds, and worldwide consequences. The world's biggest weather maker is calling. Let's get started. El Niño, Spanish for the little boy, was first noticed by South American fishermen when warm waters replaced the usual cold ones near Christmas. This warming disrupts marine life, as fish that thrive in cold, nutrient-rich water vanish. At its core, El Niño is a temporary but dramatic warming of the tropical Pacific Ocean. Normally, trade winds push warm water west, piling it up near Australia, while cold water rises near South America, a process called upwelling. During El Niño, the warm water sloshes back east, shutting down upwelling and releasing huge amounts of heat into the atmosphere. This isn't just a local event, it's a coupled ocean-atmosphere phenomenon that shakes up weather patterns worldwide. The feedback loop between ocean and air can last months, setting the stage for dramatic global weather changes. Next, let's see how this all begins, with the winds. The story of El Niño starts with the trade winds, steady breezes that usually blow warm Pacific water westward. Every few years, these winds weaken or even reverse, letting the warm water surge back east. This shift shuts down upwelling off South America, starving marine life of nutrients and disrupting fisheries. The warm water heats the air above, further weakening the winds in a self-reinforcing cycle. As the ocean and atmosphere feed off each other, El Niño conditions intensify and persist. The result: a powerful feedback loop that can last for months, transforming weather across the globe. It's a striking example of how tightly the ocean and atmosphere are linked. When this balance tips, the effects are felt far beyond the Pacific. Now, let's see how El Niño's reach extends worldwide. Once El Niño takes hold, it sends shockwaves through the world's weather. This powerful climate phenomenon doesn't just affect the Pacific Ocean, it sets off a chain reaction that can be felt across every continent. The atmosphere becomes a global stage, with El Niño as the main actor, shifting the balance of weather systems everywhere. The extra heat and moisture in the Pacific shift the jet streams, those high-altitude rivers of air that steer storms. These jet streams act like invisible highways, guiding weather patterns thousands of miles away. When El Niño changes their course, it can alter the timing, intensity, and location of storms, sometimes in unpredictable ways. In the US, the Pacific jet stream often moves south, bringing wetter, stormier winters to California and the Gulf Coast. Cities that are usually dry can suddenly face relentless rain, while rivers and reservoirs fill rapidly. Flood risks rise, and communities must prepare for weather that feels out of the ordinary. Meanwhile, Australia and Indonesia can face severe droughts, as rain that would fall there shifts elsewhere. Crops wither, water supplies dwindle, and wildfires become more likely. The land itself seems to thirst for relief, but the skies remain stubbornly dry. El Niño also brings warmer winters to parts of North America, blocking Arctic air from moving south. This means less snow, milder temperatures, and a winter that feels strangely gentle in places that usually brace for the cold. These changes can mean floods in one place, wildfires in another, and ripple effects on agriculture, water supplies, and even the ski industry. Farmers may struggle with unpredictable growing seasons, while ski resorts face shorter seasons and less snow. Water managers and emergency responders must adapt quickly to new challenges. The altered weather patterns can last for months, affecting millions. Families, businesses, and entire communities must adjust to a new normal, sometimes with little warning. El Niño's global reach is a reminder that no region is isolated from the world's climate engine. From bustling cities to remote villages, everyone feels the impact in some way, whether it's through food prices, water shortages, or unexpected weather. But the story doesn't end with just rain or drought. Sometimes the swings are even more extreme. El Niño can tip the scales toward record-breaking hurricanes, devastating wildfires, or catastrophic floods, leaving a lasting mark on landscapes and lives around the globe. Climate whiplash describes the dramatic and often unpredictable swings in weather that can occur over a short period of time. Imagine a region suffering from a prolonged drought, only to be hit by torrential floods just days or weeks later. These rapid shifts between extremes can catch communities off guard, making it difficult to prepare for what comes next. At the heart of climate whiplash are powerful global forces like El Niño and La Niña. These climate patterns, driven by changes in Pacific Ocean temperatures, can dramatically alter weather across the globe, setting the stage for sudden and severe shifts. Take California, for example. The state can endure years of relentless drought, leaving reservoirs empty and soil cracked. Then, when El Niño arrives, it can unleash a series of powerful storms that overwhelm the dry landscape and strain aging infrastructure, leading to widespread disruption. The aftermath? Flash floods that sweep through towns, destructive mudslides that threaten homes, and massive erosion that reshapes the land. These events can happen with little warning, compounding the damage. But climate whiplash isn't limited to rainfall. It also brings wild temperature swings. One week might feel like spring, and the next, a deep freeze sets in. These abrupt changes can disrupt daily life and challenge even the most prepared communities. For farmers, these rapid shifts are especially devastating. Crops and livestock are highly sensitive to weather, and sudden changes can ruin harvests, reduce yields, and threaten food security. Recovery can take months, or even years. Natural ecosystems are also under pressure. Trees weakened by drought are more likely to topple in storms, while wildlife may be forced to flee or adapt quickly to survive. The balance of entire habitats can be thrown off by these rapid changes. Emergency responders face a daunting challenge, preparing for wildfires, floods, and everything in between, sometimes all within a single season. Their work is more critical than ever, as these extremes become more common. That's why accurate forecasting of ENSO swings is essential. By understanding and predicting these patterns, communities can better prepare, adapt, and build resilience against the unpredictable forces of climate whiplash. Next, let's take a closer look at how El Niño's impacts unfold in real life, and what we can learn from these dramatic events. El Niño's effects are personal and immediate, shaping lives, economies, and health. In Australia and Southeast Asia, El Niño often means relentless drought, crippling agriculture and causing water shortages. Wildfires become more likely, threatening homes and wildlife. Meanwhile, places like Peru and Ecuador can be inundated with torrential rains, leading to devastating floods and landslides. Infrastructure is often unprepared for these extremes, resulting in billions in damages and mass displacement. Floodwaters can also trigger outbreaks of diseases like malaria and cholera. Energy supplies suffer too, as droughts lower hydroelectric output and floods damage power lines. Whether it's famine from drought or disease from floods, El Niño's reach is felt in every aspect of daily life. Preparing for these impacts is essential for communities worldwide. But could El Niño's influence become permanent? Scientists are asking if repeated powerful El Niño events could permanently shift regional climates, especially as the planet warms. For example, the UK and Ireland are seeing milder, wetter winters, possibly linked to altered jet streams from strong El Niños. If these patterns become the new normal, what was once temporary could become permanent. This is part of a bigger question. How does natural variability, like ENSO, interact with human-driven climate change? Today's El Niño events happen on a warmer planet, making their impacts more intense. Super El Niños could push some regions past climate tipping points, changing weather for generations. That's why ongoing research and climate modeling are so important. Understanding these risks helps us adapt to a future where the climate may not behave as it has in the past. El Niño's counterpart is La Niña, the cool phase of ENSO. During La Niña, trade winds strengthen, pushing warm water even farther west and boosting cold upwelling off South America. This cools the eastern Pacific and has the opposite effect on global weather. Australia and Indonesia get more rain and floods, while the southern US turns drier and warmer. La Niña can bring relief to some regions but hardship to others, flipping the script from El Niño. Even so, global warming means that today's La Niña years are still warmer than El Niño years decades ago. The natural cooling of La Niña can't offset the planet's overall warming trend. Instead, it adds complexity, fueling the wild swings of climate whiplash. As of late 2025, we're in a La Niña phase, shaping weather worldwide. Understanding both sides of ENSO is key to predicting what comes next. Why does all this matter? Because forecasting El Niño and La Niña helps us prepare for extreme weather months in advance. Farmers can adjust crops, health officials can brace for disease outbreaks, and emergency agencies can plan for floods or droughts. These forecasts save lives and livelihoods, turning science into action. As the climate warms, ENSO events may become more intense or frequent, raising urgent questions for scientists. Satellites, buoys, and ships gather data to improve our models and predictions. Every new event teaches us more about our interconnected world. By understanding El Niño, we empower ourselves to adapt and build a more resilient future. That's a scientific mission worth pursuing.